In this video, I'm going to talk about transformers. What's the use of a transformer? It can change the voltage. So transformers are devices that are used to change the voltage. Change the voltage. It only works with AC current, alternating current. We need a change in current for the transformers to work. The basic working principle of transformers is mutual induction. Mutual induction. There are two coils. Any change in the current flowing through one of these coils would induce an induced current in the other coil. This is called mutual induction. That's the basic working principle of a transformer. Transformers are devices that are used to change the voltage. Change can be of two types, either increase or decrease. So increase or decrease. So there are two types of transformers. There is a third one as well that doesn't really change the voltage but is used to eliminate any DC components. But why do we do that? Why do we need to change the voltage in the first place? This is mainly for long-distance power transmission, for an efficient long-distance power transmission. We need to increase the voltage before we transfer the power to distant places. There's a reason for that. So let's say at a power station, this is a power station, power plant. 50,000 watts of power is being generated. Voltage is, let's say, 1000 volt, such as random numbers. So current should be 50 amps, right? 1000 times P equals VI. 1000 times 50 is 50,000 watts. But if you transfer the power at low voltages, you would end up with a lot of energy loss. How can we reduce this energy loss? Energy loss is mainly in the form of heat. The equation for heat energy, E is energy, it's heat energy, E equals I squared RT, where I is current, R is resistance, T is time. So there are three ways you can change the energy. You can't really change the time. So to decrease the energy loss, you can lower the resistance or lower the current. Lowering the resistance is a bit difficult. You need really thick wires, so it's not cost effective. There is a better way. Reduce the current. Okay, if you reduce the current, you can reduce the energy loss. It would go down. There is an added benefit. E is proportional to I square. If you decrease the current by half, energy loss would be 1/4 times. Okay, if you decrease the current by a third, energy loss would be 1/9 times. If you decrease the current by 1/4, the energy loss would become 1/16 times. Now, how do we decrease the current? P equals VI. Power remains a constant. So to decrease the current, we need to increase the voltage. Let's say current is going down by a half, voltage becomes 2V, then only the power remains a constant VI, right? So to decrease the current, we need to increase the voltage. So at this power plant, we are increasing the voltage. Okay? So we need to increase the voltage. Then we are transferring this power, 50,000 watts. There is no change in the power, we're just changing the current and the voltage. We have increased the voltage to, let's say, 50,000 volts. 50,000 volts. That's the voltage now. Current is just 1 amps. Okay, so if you multiply these two numbers, you'll still get 50,000 watts. But we need to lower the voltage before transferring to different houses for safe use at home. Decrease voltage. So the same power can be transferred to different houses. 50,000 watts is being produced at a power station. Voltage is 1000 volt, current is 50 amps. We need to increase the voltage before we transfer this power to decrease the energy loss, and we should decrease this voltage before transferring the power to different houses. So there is a need for increase in voltage and decrease in voltage, right? So to increase the voltage, we use a step up transformer. Step up transformer. And to decrease the voltage, we use a step down transformer. So one more time, transformers are devices that are used to either increase or decrease the voltage. Transformers that are used to increase the voltage are called step-up transformer, that are used to decrease the voltage called step-down transformers. Now, how do you draw the diagram of a step-up transformer? Step up. So I told you the basic working principle of a transformer is mutual induction. So we need two coils. This is the primary coil. We supply input to the primary coil. This is the input. Primary coil. And we take output from the secondary coil. This is the output. This is the secondary coil. In a step-up transformer, number of turns in the secondary is greater than the number of turns in the primary. So it's a step-up transformer. Now, how do you draw a step-down transformer? Again, we have two coils. This is the primary coil. Primary. We supply input to the primary coil. And we take output from the secondary coil. This is the secondary coil. That's the output. Secondary. And the main difference is number of turns in the primary is greater than the number of turns in the secondary. So that's a step down transformer. What about voltage? Voltage in the secondary is greater than the voltage in the primary. It increases the voltage, right? Step up transformer increases the voltage. And for a step down transformer, voltage in the secondary is less than that in the primary. It's a step down transformer, decreases the voltage. What about the current? Current is inversely proportional. So current in the primary is greater than current in the secondary for a step-up transformer, and current in the primary is less than current in the secondary for a step-down transformer. Number of turns is directly proportional to the voltage. So number of turns in the primary is directly proportional to the voltage in the primary, and number of turns in the secondary is directly proportional to the voltage in the secondary. To remove the proportional sign, I'm going to divide these two equations. So NP over NS is equal to Vp over Vs. Now what about the current? Current is inversely proportional, right? So how do you write the equation for current? So we have primary at the numerator, but for current it should be the opposite, secondary, Is over Ip. Yeah. So number of turns in the primary over number of turns in the secondary equals voltage in the primary over voltage in the secondary equals current in the secondary over current in the primary. Let's solve a problem now. A step-down transformer has 7,500 turns on its primary coil and 125 turns on its secondary coil. The potential difference across the primary circuit is 7.2 kilovolt. What is the potential difference across the secondary circuit? If the current in the secondary circuit is 36 ohms, what is the current in the primary circuit? So we have a step-down transformer. I'm going to draw a step-down transformer. Number of turns in the primary is greater than that in the secondary. We provide input here and we take output from here. This is primary, this is secondary. 7,500 turns on its primary, so this is NP. Number of turns on the primary coil is 7,500. And number of turns on the secondary coil, this is NS. NS is 125 turns. The potential difference across the primary circuit is 7.2 kilovolt. This is VP, potential difference across the primary. So this is VP. VP equals 7.2 kilovolt. Convert kilovolt to volt. Multiply with 10 to the power of 3. We need to find the potential difference across the secondary coil. So we need to find VS. VS. Our equation, the number of turns is directly proportional to voltage. So NP over NS is equal to VP over VS. We need to find VS, cross multiply. VS times NP equals VP times NS. We need to find VS, so we need to remove NP from the left hand side. So divide with NP, VP times NS over NP. VP is 7.2 times 10 to the power of 3, NS is 125, NP is 7,500. 120 volts. It's a step down transformer, so it should decrease the voltage. The voltage in the primary is 7.2 times 10 to the power of 3, that is 7,200 volts, and voltage in the secondary is 120 volts. Yeah, the voltage has decreased because we have used a step down transformer, so our answer makes sense. Now part B. This is a step down transformer, so it should decrease the voltage and increase the current. Current in the secondary is 36 ohms. So the current in the primary should be less than 36. We can use the equation NP over NS equals IS over IP, because number of turns on current they're inversely proportional. You can also use the equation VP over VS equals IS over IP. You'd get the same answer. I'm going to use the first equation. What is NP? Number of turns in the primary, 7,500. Number of turns in the secondary is 125. Current in the secondary is given 36 ohms. Current in the primary is unknown. Cross multiply, 7,500 IP equals 36 times 125. So IP equals 36 times 125 over 7,500. 0.6 ampere. Current in the primary is 0.6 ampere. Yeah, answer makes sense because a step down transformer should increase the current. Current in the primary is 0.6 and current in the secondary is 36 amps.